Okay, so I got a little carried away on the last video and did not realize that the video had cut off on me, so I'm not exactly sure where I ended, so I'm going to kind of backtrack a little to make sure we're on the same page. So we had this first spring that was compressed, and so when I push the mass upward, I'm having to apply another force there, by the way. I'm having to push it in some way, but I'm pushing it upward. Here it would be at a position above where I'm calling x is equal to 0. And being above where I call x is equal to 0 is going to make me have a positive final position and therefore a positive change in position. But then if I turn around and look at our same scenario that we looked at in our lab, where I'm stretching the spring, so I'm adding the mass to the end and it's going to pull the spring out, ignore how crazy that spring ended up being when I drew it, then our final position for this spring is going to be down here below what we're calling x is equal to 0, which will make it have a negative final position. Okay, so this first scenario, I have a positive change in position. In the second, I have a negative change in position. And so then if I think about the force from a spring, this stretched scenario is the same as the lab we did, and we said that that force from the spring was pulling upward. So here I have a positive force from a spring. But if I'm here and I'm looking and thinking about compressing the spring, okay, the spring would no longer pull up on the object, but the spring would want to push down on the object. So if I were to let go of that mass, then that mass would be moved downward from the spring that I've now compressed. So the force from the spring in this compression scenario is a negative force from a spring. So then I can see in my two scenarios, this first one, I have a negative force from a spring and a positive displacement of my spring. And then here in the second, I have a positive force from the spring and a negative displacement of the spring. So in both of those scenarios, my force and my displacement, they have opposite signs. So they are in opposite directions of each other. So that will always be the case with a force from a spring. The force will be in the opposite direction of the direction that you push or pull on the spring. Okay. And so when we're looking at this Hooke's law, when they write it down like this, that's why they add in the negative. The negative is intended to tell you that those should be in opposite directions. But again, when we do our forces questions, we're going to use this equation for the magnitude of a force from a spring, and the directionality portion is going to come from our summing of our forces and deciding is that force positive or negative in our scenario. Okay, so let me know if you have any questions, but that is the big main bits that we should have been getting from this spring force lab. So now we have an equation for a force from a spring, just like we have an equation for the force of gravity, and that starts to get ourselves ready and set up to solve some example set questions. Bye, guys.